Assalamualaikum. Hi guys. In this video, we are going to continue with the derivatives of octahedral. Octahedral is the last basic molecular shape that we've learned so far, and the class for octahedral is AB6 because we have 6 bonding pairs. So this is how we draw the structure for the molecule with octahedral shape. The bond angle between two bonding pairs is 90 degree. However, when I replace one of the bonding pairs, for example, I took it from here, I replace this bonding pair with lone pairs, so I will have another shape which is square pyramidal. So it's just like you have a square shape, and then you have a pyramid. So that's why the name of it is square pyramidal. The class will be AB5E because right now you have 5 bonding pairs and 1 lone pair. And the bond angle between two bonding pairs is less than 90 degree because the repulsive force between lone pair and bonding pair will push the bond angle to make it much more smaller than usual. Now, contoh kalau saya ada another one more shape where I replace this bonding pair and this bonding pair opposite to one another with lone pair, I will have another shape is square planar. So square planar ni adalah macam plane lah, petak. Okay, dia landai. Okay, dia satah saja. So this is the shape for square planar where the class will be AB4E2. And the bond angle between two bonding pairs is 90 degree. This is because the repulsive force between a lone pair and bonding pair opposite to one another sama. So that's why daya tolakan dia tu memang sama. Sebab itulah angle dia kekal sebagai 90 degree. Let's try a few examples here. We go for example 13 first. So I'm going to draw the molecular geometry for BrF5. First thing first, we are going to draw the Lewis structure. So I have Br is 7 electrons and then 5 fluorine means that 5 times with 7 electrons, I have 35 electrons. So the total will be 42 electrons. Next, I'm going to choose bromine as my central atom because it's much more electropositive than fluorine. So Br will be the central and I have 5 of it. 1, 2, 3, 4, 5. And then each of them attached to fluorine. So you use up already 10 bonding pair electrons. So that's why the left will be 32 electrons. After that, I'm going to put each fluorine will have 3 bonding pairs. And then you use up already 30. So minus 30 electron. The leftover will be 2 electron. So the 2 electron here will be put at the central atom. Minus 2 electron, you get 0. So this is the Lewis structure for BrF5. Now, we are going to determine the molecular geometry by calculating their bonding pair. So, around Br, sekeliling bromine, kita hanya tengok dekat bahagian central atom. Around Br, we have 5 bonding pairs and we got 1 lone pair here. So, the total electron pair should be 6. So, bila 6 saja, basic shape dia adalah octahedral. And the class will be AB5E. Because we have 5 bonding pairs and 1 lone pair. And the molecular geometry for this case bukan lagi sama macam octahedral, tapi dia berubah sebab ada presence of lone pair, which will be square pyramidal. And the bond angle will be less than 90 degree. So now I'm going to draw the correct molecular geometry in square pyramidal shape. We are going to start by drawing the central atom Br, and then I have 1 in plane attached to fluorine. This is 1 bonding pair, and then we got 2 bonding pairs showing to the back and 2 bonding pairs showing towards the plane. Then each of them bonded kepada fluorine. And last one, we have lone pair. Okay, that's why this is the shape for square pyramidal. Don't forget to put the lone pairs around the fluorine. And last but not least, the bond angle, which will be from here to here less than 90 degree. So this is the structure for square pyramidal of BrF5. Let's try the next example, SE-F4. SE, we have the valence electron is 8 because it is one of the noble gases. And then we have 4 fluorine. So 4 times 7 electrons should be 28 electrons. And the total will be 36 electrons. After that, I'm going to choose Se as my central atom. And then it bonds to 4 fluorine atoms. And then we use up already 8 electrons. So minus, we have the leftover is 28 electrons. These 28 electrons, I will put as a lone pair around fluorine. So each fluorine got 3 bonding pairs, like this one. So we use up already 24 electrons. So the leftover will be 4 electrons. So these 4 electrons I'm going to put at the central atom. And after that, minus 4 electrons, you got 0 electron left. Now, this is my Lewis structure for SE-F4. So from this Lewis structure, we have around xenon, Xe, we got 4 bonding pairs. And then we got 1 and 2 lone pairs. The total will be 6 electron pairs. So bila 6 sahaja, kita tahu basic shape dia adalah octahedral. So from this part, we can know that due to the presence of lone pair, when we have 2 lone pairs, the molecular geometry will be changed to square planar. And then after that, the class will be AB4E2. And the shape right now changed to square planar. And the bond angle will be equals to 90 degree. So now I'm going to draw the correct molecular geometry for SE-F4. So we're going to start by drawing the xenon as a central. And then after that, I have 2 lone pairs opposite to one another. And then we got 2 dashes and we got 2 wedges. Each of them bonded to fluorine. And the next one, I'm going to put the lone pairs around each fluorine. So this is the structure when you put the lone pairs around the fluorine atom. And last but not least, the bond angle from here to here is 90 degree. So this is the molecular geometry for SE-F4. So from here, we only got the 2 derivatives of octahedral. The first one is square pyramidal due to 1 lone pair. And the second one is square planar because of 2 lone pairs. All of them is derivatives of octahedral with class AB6. So as a summary for all the basic shapes that we've learned so far, we got AB3 trigonal planar, AB4 tetrahedral, AB5 trigonal bipyramidal and AB6 octahedral. So ini semua adalah basic shape yang kita belajar dan termasuk dengan linear AB2. Dan daripada 5 ni, hanya 4 sahaja yang mempunyai derivatives kerana kita ada lone pair dekat central atom. So dia akan berubah mengikut bilangan lone pair. So you can see that from here. So this is what I explain based on molecular geometry. Maksudnya molecule with lone pair. So sampai situ sahaja for this video. I hope you can finish try this 2.0 as your exercise. Thank you for watching. Bye.